Hi everyone, so welcome to the first demo video in understanding one of the LCA software, CIMA Pro. So in this video, I'm going to show you some of the basic standard user features on using the software of CIMA Pro. So there are basically 8 features that we are going to try throughout the video, which is inspect the goal and scope, inspect processes in the database, analyze the parameter profile of a product, generate a process network, analyze the full life cycle, and last, we will compare two products in the production stage and also in the life cycle stages. Then lastly, I'm going to show you how to select or inspect a method. So throughout the information or the examples going through these 8 features, we'll be using examples of uh, coffee maker machine. So these are already been developed inside the software. So in this video, you are not required to insert or to do any modeling. So everything is already pre-developed. So we are just exploring. So we'll be using the example of two coffee maker machine. One is model CIMA and another one is model Pro. So the difference between model CIMA is model CIMA is mainly made from plastics and it has a hot plate system to keep the coffee warm. Whereas model Prima is mainly made by using aluminium and it has thermal jugs to keep its coffee warm. All right, so without further ado, let's get started. So to get this, we have to launch the CIMA Pro software. So like I said, because this project is by default available in all version of CIMA Pro. If you are in a demo version, you are still have it in your software. So what we need to do now is we just need to open this project. So this project is Introduction to CIMA Pro. Okay, so you need to open it. So like I told you mentioned just now, all libraries or all processes related to model CIMA and model Pro are already inserted for you. So we do not need to key in any data input or output in this exercise. All right, so let's see. The first things that we can do is to inspect goal and scope. So since it's already there for you, so they have already inserted the goal and scope. Where do we find the goal and scope? Okay, so on the left hand toolbar, you will see goal and scope. So on the description, so it is a template of all information needed when we are reporting life cycle assessment exercise. Example, date, and then the author, comment. You can insert whatever comment you have for your own reference or for your readers understanding. And then LCA types. What is the objective? It is internal screening or it is for external communications. And most importantly, we have to identify the goal. What is the objective of this exercise? All right. Okay. Of course, throughout the exercise, we can do a lot of things. You can try out a lot of things, but we have to stick to the main goal of this project. Okay, which is to analyze the life cycle of a making machine, and we need to compare between two different types of coffee maker machines. And then lastly, I would like to highlight the functional unit. So functional unit is very important because when we are communicating the result with third parties, it has to be clear that which size of scope that we are investigating, so that it won't give a misleading information to other people, especially when they are comparing your result with others. All right. So if you are starting a new project, all this will be blank and you have to insert it on your own. But since this is just an example, so everything is already inserted for you. So this is a good example of goal and scope informations. Of course, some users may do not prefer to type in their information here. They prefer to save it in the other software like worksheet or spreadsheet, right? You can do it there, but just to tell you, this software provide you a space for you to uh, key in and save all information that is relevant to this project, so that in future you can refer back and it's easy for you to find. Okay, so under the goal and scope, there's library. So library store the available or access databases that you has subscribed to. So in this case, I have subscribed to databases from AgriFootprint, databases from Eco Inventory, and other databases from different countries. Okay, so in this case, we are not going to explore these databases. So that is the first features, inspect the goal and scope. So under the goal and scope, there are only descriptions and also library. Now we are going to inspect the processes in the database. So the processes will fall under the category of inventory. All right, so when we click on the processes, so you will see there are one main folder. So under the main folder, there are a number of subfolders which carries the name of material, energy, transport, processing, use, waste scenario, and waste treatment. So when you see a positive sign here, means it can be further expanded. So when I further expand this material, so in the folder of material, there are a few more subfolders, which chemicals, construction, glass, metals, others, paperboard, and plastics. So when you are a new users, normally if you are not subscribing to any database, so basically these folders are by default and basically they are blank. So let's inspect. If I further expand chemical folder, there will be a few more folders, acid, inorganic, other silicon washing agents. So when it comes to a negative sign, means it cannot be further expanded anymore. So when I click on it, if there is any stored or any databases available, so the databases will appear in this section. So here when I click, there's nothing, means I do not have any stored databases here. So for acid, there's nothing here, nothing here. So this is how we inspect. So basically, we are free, or it is flexible for us to actually move the folder anywhere we want, and we are able to create new folder in future. If you are creating processes which is not falling into the group of the folders that are available in this list, you can create a new folder on your own. So I'm going to show you how do we create a new folder. Example, I'm going to create an energy. All right, so I want to create energy which fall under the list of here. So I'm going to create energy or electricity in Malaysia. So here, when I highlight the energy, this is where I want. So if it allows me to create a new folder, then this new will appear. All right, so oh, I apologize. So this new is for the processors. It would like to, if I would like to create a new folder, when I click on the energy, I need to right click. Okay, when I have a right click, then it will show this list of command. So I will click on new category, then I will name it as electricity in Malaysia. Okay, when I click OK, you will see that this electricity in Malaysia fall under this energy group. Okay, and you may ask, can I further create subfolders under this electricity of Malaysia? Actually, you can. You click on it, highlight it, right click, new category, and then let's say electricity in Kuala Lumpur. Means this is a sub or region in the country, So you will see under this electricity of Malaysia, when you expand it, then there will be electricity in Kuala Lumpur. All right. So how do we delete? If we later on we find these folders no longer in use, we can highlight and then write on it, right click on it and delete. And please bear in mind, if you have processes already saved within this folder, you are not able to delete the category because it will affect the databases which is already stored in this folder. So you have to delete all other processes which is in this folder, then only you can delete the folder completely. So I'll be able to delete it. So do you want to delete the category and all its subcategories? Yes, I do. Then it will just disappear. So if I want to delete this one, then it will be just disappear. So this is the processes in the database. All right. Now, if let's say I have already created, I would like to, when I click on electricity by field, there are coal, gas, hydro, lignite, nuclear, and I have another one is from maybe energy from biomass. Okay, there are no biomass here. I would like to create one energy from biomass. So I will create biomass, and then this new folder will appear, okay, under electricity by fuel, this biomass things. Okay, so you see is fall in the first because they are actually alphabetically in order. We start with B and then followed by C. So now I'm going to create a process under biomass. All right, to create a process under biomass, I click on it, then you will see this new button. This new button is to enable you to create processes. All right, so now let's assume we are going to create one process to generate energy by using biomass. Okay, so in order to create this, then let's inspect what are the things that what are the template that will be provided to us to insert in order for us to create a process. So you click on new, so you will see. All right, let me enlarge it. So these are the template. So there are actually 4 sections or 4 pages. The first page is on the documentation. On the documentation, it provides empty spaces for you to key in information regarding the databases that you are going to insert. Like example, name. All right. So you can click on the name. Example, energy, electricity from palm oil mill by using empty fruit branch. Okay, so the process types, so you will need to choose is either a unit process or system. Because this is just a small process, so you will choose unit process. Very seldom you will choose it as system. Is a system means it's already a completed one, means it already cover from many stages like a life cycle system. Yeah. So when you create a new one, an identifier means a reference number will be automatically assigned to you. So means whenever the system will track this process by using this reference number. So on the comment correction method data treatment, so it is actually free for you to key in. So is it a primary data? So when do you get it? Do you have any verification by any third parties? So if you do, then you will insert the information in it. So with that, then you completed documentation 1. Basically, it is not mandatory for you to insert anything in documentation 1. It's just for your own references. So whatever you insert here, it will not affect your analysis, because when they want to analyze this process to convert it to quantify it into environmental impact, they will need information in the second page, which is the input output. So input output is basically the main information which is required for the system to capture, to quantify them and convert it into environmental impact and damages. So on this second page, you will see there are actually basically 3 sections. Product section, which is on the top, followed by input sections, and lastly output sections. So in these product sections, so there are basically 2 subsection for you to insert. The first one is the product. So you have to bear in mind, whenever any single process that you are creating, there must be a product. The product can be tangible, it can be non-tangible. Tangible product, it can be any physical product. It can be in mass, it can be in volume, it can be in others. And some intangible product can be services, can be an activity, can be a policy. So it does not limit you to put in anything there. So let's say I'm going to say electricity is intangible product. You cannot see it, but it is something like a service. Yeah. So yes, electricity. Okay. So this is one of the product here, and because it say you can put in more products and co-products, so basically I can add. To add, I just click on this button, electricity, maybe a heat. Okay. So now the amount for you to put it in. So electricity, because you see the unit is kg, we have to change it. All right. So like I said, this quantity can be changed. It's so flexible that you can include tangible and non-tangible products. So electricity, it cannot be measured in mass. So we have to change the quantity first. Double click on it, and there's a drop down list here. So there are, when you scroll it down, amount, area, currency, dimensionless, and then energy, indicator, land use, length, a lot, even time, transport, volume. Okay. So noise. So electricity is measured in energy. So when we click on energy, the unit will change accordingly. So it can be in joule, kilojoule, megajoule, gigajoule, and WH, kilowatt hours, and all this. So let's say we put it as kilowatt hour. So let's say our reference unit is maybe 1 kilowatt hour. Okay. Then for heat, so we have to know how heat is measured. Heat cannot be measured in mass, so heat can be measured in energy as well. So energy, all right. So heat can be measured in joule. So I will put it as joule. So maybe a 500 joule, something like that. Okay. So on the allocation part, you will have this automatically assigned. Let's say, because if you still remember, LCA is not a dynamic. When we model it, we do not model it as a dynamic process. Means we model it as a stagnant or a stable process where it does not fluctuate. So the processes will be stick, right? Let's say the input, how much of input in, and then basically it will be converted into different output in the constant percentage. It won't change. So it's not a dynamic process, but it is actually a stable process. So in here, let's say this case, the allocation of, if I put 100% electricity, means there is no percentage of heat. There's no heat generated. So in this case, I may put maybe 70% to 30%. Okay, so that is the allocation. When we key in here, then the system will capture it. Means you already allocated the allocation by percentage to the co-products. Then the system will assign it accordingly. Okay, the second output to the technosphere is avoided product. So in this case, avoided product is not the product that you really produce. It is a product that you produce that can avoid the production of the same product elsewhere. So it's going to replace other things. So it will be basically useful for recycling. Okay, so in this case, let's say the heat may we call it, may replace maybe another heat generated from another power plant. So then you will put it in here. So remember, because this output avoided product, so you cannot key in your avoided product. The product that is manufactured elsewhere, you cannot key in here. You have to create the process of manufacturing the product elsewhere as a standalone process, and then you will just link it back there. That's the reason why when you double click on the add, it will not allow you to key in what is the input and output there. So it is linking to another process which you avoid producing that processes. All right. So when you add on it, double click on it, so it will let you choose. So you have to choose from the list of folders that you have just now. Yeah. So basically here we got nothing, so we couldn't choose. So basically this is just a replacement to replace the production of other products. So of course, the more you put it here, the more avoidance products is greater to the environment, because no more production over there means no more pollutants, no more impact to the environment. Okay, so this is actually a very good place to insert if you have a lot, and it will bring excuse me, and it will bring benefit to the environment. Okay, so the amount here, all right, you will key in the amount. So in the input now, for the input to your process, like I said, in life cycle, we only quantify the material which crossing, okay, your boundary into your activities. So whatever remain inside the activities without coming out or going in is not counted. So we only quantify those that cross the boundary into your activities. So for input wise, then it is subcategorized into three different categories of input. One is input from nature, input from technosphere, which is from in terms of materials and field. Another one is input from technosphere, which is in terms of electricity and heat. So in this case, if you click on it, so you can basically find all sort of available resources that we can tap on that is known to human being. Okay, example, if you would like to find a gold, okay, you can just search, you can type GOLD and then you'll get gold here. Okay, let's say if you want to tap, you are tapping on water, which comes from resource like nature, you can type on water. So example, so you just type water, so you will get water, and there are all sorts of water. Example with river silt, water from cooling, water from a lot of things. Okay, so when you click on it, and it will provide you the information of the unit. So it is measured in kg or measured in meter square. So remember, you actually couldn't change the unit because it's already created. Okay, so example, I'm choosing one lead. Okay, so I'm going to select, so it will appear here, and then I will just need to key in how much lead that I did for this process. Right, so from input from technosphere and materials, okay, all these actually you need to refer to the processes which already available in the list. All right, so let's say you want a material. Okay, so let's say you want material which is an acid. Okay, it is already processed, and then you want to use the acid. So you double click on it, and then it pop up this list of folders. So you have to identify where the acid is. So let's say I know it is falling under the chemicals, and then acid, inorganic, and organic. So I click on it. Supposedly there must be some acid production processes here. You just need to click on it, and then it will link it there. Okay, so you will say, then can I create my acid production? Yes. Okay, you can either create it by doing now. Let's say then your output will be an acid, and then you will need to find back to do acid, how much of energy needed, how much of this needed. So you have to create the processes one by one from upstream, and then you link it to downstream, and one by one it goes. So if let's say you couldn't get the primary data for creating the process, you can still rely on libraries. So when you have access to the libraries, so all the secondary data of production of acid, generation of energy in power plant, everything is already available in libraries. You need to choose the most appropriate one and just link on them. Okay, so these input are categorized into categories: material fields, electricity, and heat. Okay, on transportation, it falls under the second one, which is the materials and fuel. Okay, so after input, then the last section will be the output. So output, emission to air, emission to water, emission to soil. So when you click on it, so there are all possible emissions, chemical contaminants that we have discovered. Okay, so there are a lot of them, so you just need to choose. Let's say this process that we are doing now create methane. All right, so you just need to click on methane. Then there are methane biogenic or methane this one. So you can click on methane biogenic and select it, and then how many kg. So you need to quantify it, maybe 72,346 kg, and you can change it to ton, kiloton, and this and that. All right, okay. So emission to air, emission to water. When you click on it, they are all chemical contaminant which can appear or can be soluble in water, or it can be go together into the river. Okay, let's say normally for water, we are very much concerned about COD, BOD. You can click on type COD, then chemical oxygen demand, and then select on it, it will appear here. Okay, so emission to soil, final waste flow, non-materials, okay, emission, everything you can click on it and explore. Okay, you might be very curious, what is the social issue here? Okay, let's explore. When we double click on the ad, so basically now at the moment they only can quantify a few social issue here, which is residual hardwood, residual softwood, venting of argon, venting of nitrogen. It's not complete yet, but there's just some examples of it. So, but normally in this case, social issue are not very comprehensively developed. So for me, we are not using it quite frequently. So that will be not our concern. For economic issues, let's explore what it has. So at the moment, there's nothing here yet. So these two issues, normally we do not quantify so much. So we are still sticking to environmental impact rather than social impact and economic impact. All right. So these are the things. And lastly is output as waste and emission to treatment. So these are the input-output table. And then on parameters, this one I'm not going to discuss now because it is on like it gives you an idea like you are working with an Excel spreadsheet, and instead of giving a real number, you can actually put in we call it equations. So you can put in equation. So it when you click on the database, then it will calculate it automatically. So parameters is where you key in your expressions. All right, you key in your equation here. For system description is like the documentation. So you just describe your system. If you have any cut rules, any allocation rules, or any transport model, or any other assumptions, so you'll be using it. So basically, we'll be using input and output table. The other three, we seldom use it at this stage. Okay, so now once we have created, so we have to save it. So let's say I created, then I want to close it. So it will answer you, data have been changed. You want to save? Yes. So when I save, you will see it will appear under my biomass and electricity and heat. You'll see that because I created two co-products, so it will happen too. When I click on it, it will link me to the same page which I already created. Electricity, lead, methane, COD. All right. If I click on heat, it will link me to the same page as well. Electricity, heat, and then methane, COD. Okay. What if I would like to edit? So you want to edit it in the later stage, easy. Click on it and you can change anything. Let's say I'm going to add one more thing. From nature, I use kelonite. All right, so select, and then I just put in the value 20 kg. Okay, so when I close, you automatically ask me whether I would like to change, would I like to save. So I'll click yes, so it will help me to save. So we can keep updating our processes from time to time. So there's the processes in the database. All right. Okay. Now, so we have completed the first one, inspect the goal and scope. We also completed the second one, inspect the processes in the database. Now let's move on to number 3, analyze environmental profile of a product. All right. So in these examples, like we say, we are referring to an example of a coffee maker machine. So let's say where it is. Let's find. So profile maker machine is already input here assembly. So if you look at this, the second product stages, just now we were in processes. Now we move on product stages. When we click on it, you will see this list of folders. So product stages, there are 5 lists of folders: assembly, life cycle, disposal scenario, and then disassembly and reuse. So assembly means simply means a cradle to gate, means everything is being extracted from the nature and being processed and produce a product, okay, without using it, produce a product. And then on disposal scenario is where how this product is being disposed and what are the waste treatment, okay. And then life cycle is basically linking assembly and disposal scenario. So it actually covered from cradle to grave. So in this case, everything is already pre-inserted for you. Let's explore. So on assembly, when I click on, I'll see 2 machine, okay, coffee machine. So when I click on it, so you'll see assembly model pro aluminum, assembly model CIMA plastics. All right, it is already being inserted for you. So now let's analyze the environmental profile of this product. So we have to understand that in this assembly, so means is only the impact is only analyzed from raw material extraction, manufacturing, and that's it until the product is being manufactured. Okay, so let's analyze aluminum. Okay, so to analyze aluminum, we just click on it. All right, so when we click on it, it will tell us, so this aluminum assembly from basically four different materials. One is the housing, okay, and then small part, and then thermal jug, and then the cable. All right, so all these are the processes that you need to create. You need to create. So when you create these, then you will need to assembly them together, means you are just putting them together. Okay, then the system will analyze this. All right. Okay, so there are some comment here, so I'm not going to go through that comment. So how to analyze? To analyze, then we have to click, when we're in this page, we have to click this button, analyze. Okay, so we click on analyze, and then there are some things that you need to insert. So for us, if we would like to save our we call it Analyse, then we have to create insert the name, and then you can save it later for your later we call it save it for your later reference. But now I do not need to save, I just want to get the data immediately, and after that I will just close it. So we just click on analyze. Okay, later on I will show you the network and compare. So let's analyze first. So before we calculate, we have to choose a method. So just double click on this part, a method. All right, so there are a few methods for you to choose. Methods developed in the European countries, global, North American, others, single issue, and water footprint and superseded. Okay, so there are a lot of methods. So let's say we are only focusing in single issue. So we are more concerned about the carbon emission. So when we click on single issue, there are a few for you to choose. Cumulative energy demand, so it's looking basically at energy consumption, and then ecosystem damage potential, greenhouse gas protocol, IPCC 2013 GWP, and then LCI result, and then USE talks 2. So in this case, let's choose greenhouse gas protocol. Okay, so it focus only on greenhouse gases. So I'll just select. Then for this product, only 1 unit. Okay, 1 unit of this Model Pro aluminum. Let's see what is the impact in terms of greenhouse gases emission. So one, we got everything here. Switches, exclude infrastructure processes. You can click and you can unclick. So it's up to you. Basically, this will not change your result much. So at the moment, we do not want to explore this yet. So let's see. We have got 1 unit of this, and let's calculate. So in this case, all right, it will give you one table, so it gives you the numbers. So if you let's interpret this result. So there are 4 impact categories which fall under greenhouse gas protocol, which is fossil carbon emission, biogenic carbon emission, carbon emission from land transformation, then CO2 uptake. All right. So everything is measured in kg CO2 equivalent, and then the total is this much. And then they will separate it into 4 different parts. Like if you remember, this coffee maker machine is made from 4 parts: housing pro, small part, thermos jar, and main cable. So every part will contribute to its carbon emission, and then for total up, you just add all this together and total up together. When there is a cross sign, means there is no carbon emission in this category, or there's no impact in these categories. Okay, so it will show you in table. Of course, you can have it in chart. So you just click on this one, you'll show you in chart. So basically, from this chart, you can draw a brief conclusions. The carbon emission impact is mainly contributed by the dark green color, which is the housing pro, means the aluminium. So from extracting aluminium to transporting aluminium to manufacturers, and then smelting it, and then making into the housing of coffee machine. So there are a lot of carbon emission being emitted. So from here we can see this one. Okay, so this is the impact assessment. So we can click on the inventory. So for every part, so it will tell you, okay, what are the inventory, what are the pollutant, how much of pollutant it is. So for this exercise, it analyzed more than 500 inventory. Okay, so that is the inventory. On the process contributions, similarly, you will have 4 part, the part of coffee machine here. So in terms of process contribution, so just now you saw inventory. Inventory means you are looking at the substances. So for process, you're looking at the process. Example of process: aluminum tube production, and then aluminum productions, copper, and then glass production, virgin glass, and then injection molding, and then PP granulate production. So all these are the processes that needed to be completed so that it can produce 1 unit of coffee machine. So in this case, we will see, okay, which one will contribute the most. All right, so examples, 1.5 kg of aluminum tube production is from here. Then 80 gram of copper, okay, contribute 20 to here, and then let me, okay, so 60 to here. So this is the process contribution. This is not telling you the impact here. It just tells you what processes are being calculated. Okay, so that is the impact assessment. All right. So now number 4, generate a process network. So a process network, because it gives us an idea how this coffee machine is being made. What are the flow diagram? So to do it, this software actually can help you to generate the network. So if you see the button of network here, you just click on it, then it will help you to calculate. So it appears this flow diagram or tree diagram. So everything will contributing upward. So this is your final product, assembly of aluminium. 1P means 1 unit. So it required 4 parts, which is the blue color one, Housing Pro, small part for model, and then thermos jug, and then mains cable. So from this, there are green. Green means material. And then for yellow, it means processing. So there are a lot of things here. All right. So it also tell you like what is how much contributed. It tells you in the number. You actually can change. So you can change it into inventory. All right. Or you can change it to single product flow. Okay. So you can change your viewing. Okay, so you can change your CO2 biogenic CO2 equivalents. Okay, change, then will give you another result. So you can change, you can try to interpret like CO2 from land from transformation. Okay, so if you still remember just now, there was it was not much, so you can have a look. You can zoom in, you can zoom out. Okay, so that is basically the network. Okay, one more thing I would like to highlight according to the network is the cutoff, because maybe there are a lot, so we can actually simplify to things which is only significant to us. So there is a cutoff here, 1.77%, which means whatever impact which is bigger than 1.77% will be shown here. If it is smaller than 1.77%, it will be hidden. All right, let's increase this. If it increase, means the cutoff is increased, means these processes which is not significant, it will be reduced. So when I increase it, you see the boxes will be reduced. Okay, so if I reduce the percentage to 0 point something percent, so the boxes will be expanded, means it's unhidden. All right, so this cutoff rule is just to hide any process which is considered insignificant so that the whole network looks simple. If I put 0, then let's see whether 0.0001, let's see. All right, I think this is basically the most comprehensive one. So if I put 50, so there are only 2 process which contribute beyond the cutoff rules here. So these are the things, and you can actually export this. To export this, you just need to click export. So at the moment, it does not allow you to export. Okay, yeah. So that's it. So basically, this is the first part of the video. We have already gone through 4 features: inspect, go, and scope, and then inspect the processes. We have gone through the, okay, let me okay, we have gone through the first 4 features. We inspect the go and scope, we inspect the processes in the database, we analyze the parameter profile of a product, we generate a process network. Okay, so basically this is the first part of the video, and then we'll come back at the second part of video to cover features number 5, 6, and 7, and 8. So that's all. Thank you very much.